So you have a curling rock, it's 19.9 kgs, slides for 28.8 meters until it comes to a stop. The coefficient of friction with the ice is 0.105. We know how much thermal energy is produced during the slide. Well, thermal energy is just the heat produced. In this case, it's due to friction. So essentially, we want to know how much friction is exerted by the rock on the ice. So the thermal energy was all of the kinetic energy that it had. This rock has no potential energy. It's not off the ice. And we have nothing but kinetic energy. Well, kinetic energy, we need the mass and the speed. We don't have that. So let's go with the definition of energy. Energy is the same thing as work. And we know that work is force times distance. Well, we know the distance that this rock travels, but the amount of force exerted by the ice would be due to the friction on the ice. And this is kinetic friction. So the other thing we know for force, the force of kinetic friction is mu k times Fn. Which is also mu k times mg, because F equals ma, but the normal force is due to gravity, so A becomes g here. So knowing this, we can find the force of friction. Mu is 0.105, m 19.9 kgs, and g, as always, is 9.8 meters per second squared. So the force of friction, and I'm not going to round to sig figs, this is not a final answer, 20.4771 newtons. Well, now that we know Fk, that is the force up here that's exerted in order to do the work. The work is slowing down the rock. So then we know, going back, that work equals force times distance. We have a 20.4771 Newton friction force, which takes 28.8 meters to stop this rock. Multiplying that out, and we get that there is 590 joules of work done, or, looking at it the other way, the kinetic energy of the rock was 590 joules when it began moving. Question B, one of the rock's speed just as it left the player's hand. Well, this is related to kinetic energy. And since work and kinetic energy are the same, both 590 joules, we can deal with that. So kinetic energy, 1/2 mv squared. Ek, we know, is 590 joules. M, 19.9 kgs. Let's try that again. And V we don't know. Multiply that 1/2 times 19.9, we get 9.95 V squared on the right. Divide both sides by 9.95 and we get 59.296 equals V squared. Take the square root of both sides, and going to 2 sig figs, we get that V is 7.7 meters per second.